Hi guys, and today I will welcome you to my Minecraft educational video. Now, this is where I will present to you and educate you on intermolecular forces and on solid, liquid, and also gas, and show you the measurement and presentation of data. Now, let me introduce you to what is a measurement scale, or what is it for. A measurement scale is an important part of data collection, analysis, and presentation. In the data collection and data analysis, statistical tools differ from one data to another. Graphs are also a common method for visual presence and illustrate the relationship of datas. So now I'll introduce you on what to do to get those measurements, starting with accuracy. Now, accuracy refers to a degree of conformity and correctness of something when compared to a true or absolute value. For example, I am going to hit number 6. And I'm gonna hit it closely again. And another one. I'm gonna try this about 3 times to show you how accurate is it. So right there shows you what accuracy is. It's consistently getting a hit on a selected number or measurement. Now, what is not accuracy is saying I hit those accurate measurements, or number 6, even though I hit the target from example all the way from over here, number 3. Yeah, no, that's not accuracy. Well, to further show accuracy, what the right word is we're looking for is consistency in getting that measurement. Okay, on to the next one. Up. Now, after accuracy, what is the second thing you need most in getting? Well, I can educate on you that right now. That is precision. Now, how do I refer to precision exactly? What's the difference between accuracy and precision? Now, precision is being more specific to what you hit or what you measure. Now, as you can see here, I have 2 measurements that are closer to each other, which is 2. And for this video, let's go call this 2.5. And let's go call this 2.9. Yeah, let's call this 2.9 right here. Flop. Now you can see this right here is accurate. You know, like 2, 2.5, 2.9. But the thing is, you could be accurate, but you could still be wrong. Like, for example, this is what I need to know, but the correct measurement that I need is somewhere around here. You could be precise on something, but being precise on something doesn't make it correct either way. So that's accuracy and precision. Now, for our last thing that I'm going to show you for accuracy and precision in the measurements, I'm going to show you what random errors are. Now, to show you what a random error is, I'm going to go hit number 10. Actually, no, here's a better example. I'm going to hit number 10 right here. But instead of calling that a 10, I'm going to call it a number 9. Like over here, I'm going to hit this, and I'm going to call that a 9.9. I'm going to call that a 9.99, even though it's still hitting 10 either way. So that is what random errors are. Now, on to the next bit. Now, over here is kinetic molecular model, and I'm going to explain you properties of solid, as you see in this ice block right here. Also, liquid intermolecular forces, and also the kinetic energy of individual particles. Now, starting with solid. Solid has a defined shape that's strongly attached to each other, just as example as this block. Now, right over here is a liquid. Now, with liquids, it has no defined shape whatsoever. It's very loose. I could like swim on it right here, as you see. Wait, let me swim on it. There we go. I'm swimming on it. So it's very loose and not really defined in shape. It could change shapes depending on what I do. Like if I add this block right here, it's gonna change shape. If I add even more to this block, it's gonna extend shape. Okay, what is it doing? Let's get rid of that right now. Oh my god, it redefined its shape. It's now a mess. Now that's one way to show you what a liquid is. Let me try and get that back. It's even more of a mess. Oh my god, what have I done? Okay. Now, after that, let's head over here to what I call intermolecular forces of attraction, which is dipole. You see here we got dipole are forces that exist between polar molecules. Each polar molecule has an unequal density. So let me show you the negative. Okay, oh no. Let me show you the negative. So right here we got the positive and we got space in between them. Now up here next is the hydrogen bonds, which you can see here we got a hydrogen bond example, which shows the polarity of water and hydrogen bonds, which is right here, just in this space right here. And last off, we got London dispersion forces. Yeah, London dispersion forces, where we've got a symmetrical distribution of electrons, instantaneous dipole moment due to asymmetry, and we got induced dipole moment in a second atom. We got a space right here to show that. So now let's go to states of matter, which is solid, liquid, gas, which is back over here in this mess that we've made. Let's get this thing actually patched up right here. Okay, no harm, no foul. So right here we've got solid, which you already know has a defined shape. We have liquids, and now we have the gas. Now the gas is more intact. The reason why gas wasn't included earlier, it's because this is now the kinetic molecular theory, which is it explains the states of matter based on the idea that the matter is compound of tiny particles that are always in motion. This explains the observable properties and behaviors of solid, liquid, gas, which is right here is tightly compact into a block. Right here is loose, and right here is even more loose, being free enough to essentially be a speck of dust. Okay, I can even fly on it. So thank you for tuning in and watching this video. I hope you learned something from it. It could either be accuracy or dipoles or the 3 states of gas. And I'll see you in the next one. Bye bye.